Good morning, students. Welcome back to chemistry online class. So you know that uh, past few classes we are discussing unit 12 carbonyl compounds and carboxylic acid. In this we have a few parts we have completed from carbonyl compounds. You know that aldehydes and ketones will comes under carbonyl compounds. Aldehydes and ketones. Aldehyde functional group representation will be CHO. Ketones, the representation will be CO. Now, in the previous classes, we have completed preparation of aldehydes and ketones properties. There are two properties are there, physical properties and chemical properties. Physical properties of aldehydes and ketones we have completed. Further, present we are discussing the chemical properties. So, in this section, we are going to carry out one mechanism. That mechanism is called as an Aldol condensation mechanism or Aldol condensation reaction. So, once again, our topic is Aldol condensation reaction or Aldol mechanism. So, this Aldol condensation mechanism will be occurs by using dilute bases. So, the reaction will be occurs by using dilute bases. Here, we can use base like sodium hydroxide, potassium hydroxide, and we can use barium hydroxide also. So the Aldol condensation reaction will be takes place by using bases, dilute bases. We can use either sodium hydroxide or potassium hydroxide or barium hydroxide. Next, we must use or the Aldol condensation reaction will be occurs only by using either by using two aldehydes or by using two ketones. So you know the representation for aldehydes as well the representation for ketones. So our point is aldol condensation will occurs by using either by using two aldehydes or by using two ketones. So for example, when we use two aldehydes as an starting material to carry out aldol condensation means our product is beta hydroxyl aldehyde, or this is also called as an aldol, right? For example, when we are using two ketones to carry out aldol condensation reaction means our expected product is beta hydroxyl ketone, or it is also called as an ketone. Then next, again this reaction undergoes dehydration. Dehydration is nothing but loss of water molecule takes place. Loss of water molecule takes place and we will get the product as alpha, beta unsaturated compound. Alpha, beta, unsaturated. So you know that unsaturated compound means our final product present are formed by double bond, unsaturated. Now once again I will repeat. Today's section we are discussing aldol condensation mechanism. So this aldol condensation mechanism will be occurs by using dilute bases. We can use sodium hydroxide, potassium hydroxide as well as barium hydroxide also we can use. As well as the reaction will be occurs by using either by using two aldehydes or by using two ketones. For example, when we are using two aldehydes means our expected product is beta hydroxyl aldehyde or it is otherwise called as an aldol. For example, when we are using two ketones means our expected product is beta hydroxyl ketone or ketone. Again, further it undergoes dehydration. Dehydration is nothing but loss of water molecule takes place, and we will get the product as alpha beta unsaturated compound. Unsaturated means you know that double bonded product. At the end of the product, we will get double bonded product. This mechanism or this reaction is known as Aldol condensation reaction. Aldol condensation reaction. Now we are saying beta hydroxyl product, alpha beta unsaturated compound. Now we should know what is mean by alpha beta like that. For example, when we are choosing one aldehyde representation, you know that CHO. For example, we can write this as C double bond O H. So this is an aldehyde representation, CHO. Aldehyde is one of the functional group. The first carbon attached with functional group is called as an alpha carbon, right? Now, in this first carbon, one hydrogen is attached. No, that hydrogen is called as an alpha hydrogen. Then functional group attached with second carbon. This carbon is called as an beta carbon. If any hydrogen will attach in this second carbon means this carbon is called as a beta. This hydrogen is called as an beta hydrogen. Now you got idea what is mean by alpha carbon, what is mean by alpha hydrogen, what is mean by beta carbon, what is mean by beta hydrogen, right? So once again I will repeat, our topic is Aldol condensation mechanism. So this reaction will be takes place by using bases. So we can use sodium hydroxide, we can use potassium hydroxide, we can use or barium hydroxide. As well as not only by using bases, we need to use aldehydes or the starting material. Either we can use two aldehyde or we can use two ketone. For example, if we are using two aldehydes means our expected product is beta hydroxyl aldehyde, or it is otherwise called as an aldol. For example, when we are using two ketones, our expected product is beta hydroxyl ketone, or it is also called as an ketone. Further, it undergoes dehydration or loss of water molecule takes place. Our expected product is alpha beta unsaturated compound. Unsaturated means double bonded product we will get. This reaction is known as Aldol condensation reaction. Next, you should know what is mean by alpha carbon, what is mean by beta carbon. So I'm giving one simple example. Aldehyde functional group CHO. Functional group attached with the first carbon is called as an alpha carbon. Attached with one hydrogen, that hydrogen is called as an alpha hydrogen. Then functional group attached with the second carbon is called as an beta carbon. This second carbon attached with one hydrogen, no, that hydrogen is called as an beta hydrogen. Now we are going to prepare these products by using 4 steps or mechanism of Aldol condensation. Mechanism of Aldol condensation will be occurs by using mechanism of Aldol condensation occurs by using 4 steps. So listen students, now we are going to carry out the mechanism of Aldol reaction. So the reaction will be or the mechanism will be takes place by 4 steps. First step, removal of alpha hydrogen atom by using base. Then, so first step you see removal of alpha hydrogen atom by using base. So in this step, our product, we will get the product as carbanion. Carbanion. So carbanion is nothing but C minus, right? Then second step, this carbanion product, or it is also called as an nucleophile. This nucleophile attack another aldehyde. So listen. So second step, nucleophilic addition of nucleophilic addition takes place with another aldehyde, and we will get the product as alkoxide ion. Alkoxide ion. The next, third step, protonation takes place. Protonation of alkoxide product. So from second step, we are getting alkoxide ion product. No, in that we are adding protons. Proton is nothing but H plus we are adding in the third step. Then finally, in fourth step, dehydration takes place. Dehydration is nothing but removal of water molecule or loss of water. So mechanism, already introduction part we have discussed. Finally, we will get the product as alpha beta unsaturated compound. So this product is called as an aldol condensation product. So the mechanism will be takes place or occurs by 4 steps. So first step, removal of alpha hydrogen atom by using base. From where we will remove this alpha hydrogen atom means by using one aldehyde. I will explain in this step. Second reaction, in the second step, finally we are getting on carbanion product. So this carbanion is also called as a nucleophile. So this nucleophile attack or addition will be takes place with another aldehyde. So if it occurs means we will get the product as alkoxide ion. Then the third step, protonation of alkoxide ion takes place. Protonation is nothing but adding H plus. Finally, dehydration. In the fourth step, dehydration will take place. Dehydration is nothing but loss of water molecule. Now we can see the step one by one. So first step one. One more thing, I already told you the Aldol condensation reaction will be occurs by using base, as well as the starting material will be, we can use either 2 aldehyde or by using 2 ketones. In this Aldol condensation reaction, I am going to explain by using 2 aldehydes as an starting material. Listen carefully. So in the first step, what is the first step takes place? Removal of alpha hydrogen atom by using one base. So I am using one aldehyde. So here we are using acetaldehyde as a starting material. Acetaldehyde. So you know the formula for acetaldehyde, CH3CHO. So right. So first step, removal of alpha hydrogen atom from aldehyde. By using base, we will get the product as what? Carbanion. Carbanion. So next, we are using acetaldehyde as a starting material. So listen carefully. For our convenient purpose, I am going to write this acetaldehyde is like this. CH2 bond hydrogen CHO. So this is an same formula acetaldehyde. I have written like this. CHO, CH2, 3 hydrogens are there now here. So CH2 bond 1 hydrogen plus we are using one base. See the step number 1, removal of alpha hydrogen atom by using base. Here general base we are using OH minus. So listen carefully. By using a base OH minus plus aldehyde. Which aldehyde we are using? Acetaldehyde CH3CHO. So further it undergoes reaction. We are going to eliminate alpha hydrogen atom. You know that this one is functional group. Functional group attached with the first carbon is called as an alpha carbon. Now this hydrogen, first hydrogen here attached. So this hydrogen is called as an alpha hydrogen. So we are going to remove this alpha hydrogen and we have added one base now OH minus. So this OH minus plus H plus will eliminated as water molecule. So plus H2O. What is remaining? So this bond will shift here. So our product is CH2 minus single bond CHO. So this hydrogen and this base OH minus will eliminated as water molecule H2O. Our product is this bond will shift here. So C becomes C minus CH2 CHO. So this product is called as an carbanion. So this is the first step. So what is the first step? Removal of removal of alpha hydrogen. Removal of alpha hydrogen by using one base. By using one base, we will get the product as what? Carbanion. Carbanion is nothing but C minus C minus. By eliminating which molecule? Water molecule. So first step over. Then next second step. You read the second step. Nucleophilic addition takes place. This carbanion product is also called as an nucleophile. So this carbanion is also called as an nucleophile. So this nucleophile addition takes place with another moles of aldehyde, right? So this one is carbanion product. No, so we can write this product here. So step 2. So in step 2, we are going to add this carbanion or nucleophile to another aldehyde. So our rule is we need to use 2 moles of aldehyde, then only we will get the product. So 1 mole we already added 1 mole of aldehyde. In the second step we are using 1 more aldehyde, right? Now you see second step, you write this carbanion product here. I am writing here CH2 minus CHO plus one more aldehyde. You know very well formula for acetaldehyde CH3CHO. So for our convenient purpose, we are writing this aldehyde structures like this: CH3 single bond C double bond O H. So carbanion or nucleophilic addition or nucleophilic attack will take place with another moles of acetaldehyde. So this is a second step. Now you see what happens. This C minus carbanion will attack or addition takes place in this carbon position. Now this bond will shift here. So it becomes O minus. Now this nucleophilic addition or carbanion attack will takes place in this carbon position. This double bond will shift here. Already oxygen is there. Now this oxygen becomes O minus. So our expected product in the second step is CH3 single bond. So we can write this hydrogen here also. Together we can write single bond CH here. This bond will shift now. So now it becomes O minus single bond CH2 CHO. So our product is CH3 CH3 CH CH. Bond will shift here. O minus O minus. This will comes here. So bond CH2 CHO. You see O minus. So this product is called as an alkoxide ion. O minus alkoxide ion. Now second step also over. You see the second step, nucleophilic addition. Nucleophilic addition is nothing but carbanion. Addition will occurs with another aldehyde, another acetaldehyde. Here we have chosen acetaldehyde as an example. No, another aldehyde and we will get the product as what? Alkoxide ion. So second step over. You see the third step, protonation of alkoxide ion. Protonation means I told you H plus. addition of hydrogen, H plus representation will be an proton, H plus. We are going to add one proton to this alkoxide ion. So you see here, so third step, step 3. So you write this product here, CH3, CHO minus, CH2, CHO. So we are adding one proton. So by using water molecule, from the water molecule we can add the proton. You know that water molecule representation will be an what? H2O. H2O. H2O, one H plus is there, one OH minus is there. So this one H plus is called as a proton. This OH minus is a base. So we can write this water molecule as like this, H plus OH minus HOH. This is nothing but water molecule. In the third step, what's the rule? We need to add one proton to alkoxide ion. Alkoxide ion is nothing but from the second step, our product is an alkoxide ion. In that alkoxide ion, we are adding one H plus proton, H plus. So listen carefully. So this is an alkoxide ion product, CH3. Same product only I have written here. CH3, CHO minus, single bond CH2, single bond CHO. Now we are adding this proton. Now this H will comes here. Now this becomes OH. So our product is CH3. This H will comes here. Proton, addition of proton, protonation of alkoxide ion. So CH3, CH, single bond, OH, CH2, CHO, plus this base OH minus. You see this product CH3, CH, single bond CH2, single bond CHO. So do you know how we can give the name of this compound? So you do know the rule. Functional group, this is an aldehyde functional group. From there we will give the number 1, 2, 3, 4. So 4 carbon is there in this product. 4 carbon is there. So the root word is but. So in the third carbon position, one OH group is there, hydroxyl. Third carbon position, third carbon la one hydroxyl group is there. So the name of the compound is 3, 3 OH hydroxyl, 3 hydroxyl, root word but, 4 carbon is there, 1, 2, 3, 4, but, aldehyde functional group. You know that while IUPAC naming time, if aldehyde functional group present means we need to use AL. So the name of this compound is 3 hydroxy 3 hydroxy butanol. 3 hydroxy butanol. 3 hydroxy butanol. Now you see, I gave some introduction part now. Two aldehydes we are using. Our product is beta hydroxyl aldehyde. So you know that this one is the first aldehyde functional group. First carbon attached with aldehyde functional group is an alpha. Second carbon attached with this functional group is called as a beta. So the product is what? 3 hydroxybutanol, or we can say beta hydroxybutanol. So third step over. Clear? Now we are going to discuss the fourth step. In fourth step, dehydration will take place. So we are writing this product there. Step 4. So same product we are going to write this product there. So the product is CH3, CH, OH, CH2, CHO. Right? So this is an third step. What is this product name? 3 hydroxy 3 hydroxy butanol, butanol or beta hydroxy butanol. Now for our convenient purpose, the same structure. You see here two hydrogen is there, no, CH2. We are going to write this CH2 as like this, CH, single bond H. CH, single bond H. So this product we can write like this, CH3. For what purpose we are writing like this means just for removing the water molecule. So while writing like this means we can easily eliminate the water molecule. For that purpose only we are writing. So CH3, single bond CH, bond OH. So this CH2 we can write as CH, single bond H, CHO. Just we are heating. You see, we are eliminating water molecule minus H2O. So this OH plus H will eliminate as water molecule. Now this bond will shift here. So our final product is CH3, single bond CH, double bond CH, CHO. So just we have eliminated water molecule outside. This bond will shift here. Now it becomes what? Double bond CH3, single bond CH, double bond CH, CHO. Now can you give the name of this compound? This is a final product of Aldol condensation reaction. Now already we have discussed in the introduction part, I told you this finally dehydration or removal of water molecule occurs and we will get alpha beta double bonded product. Double bonded, you see, double bonded unsaturated product. You check the product here, we got the product, this one. In this double bond is there. So while representing, this one is functional group. No, first carbon attached with the functional group is called as an alpha. Second carbon attached with the functional group is called as an beta. So our product is alpha beta unsaturated. Unsaturated is nothing but double bonded product. So the name of this compound, 4 carbon is there, 1, 2, 3, 4. So while IUPAC naming, we can give the number, no, 1, this one is 2, this one is 3, this one is 4. Root word but. Root word but. In second carbon, you see one double bond is there. While IUPAC naming time, double bond is there means we will use what? In. That you know very well. In we will use double bond is present in this compound means we will use double bond. So the name of this compound is but. Second carbon double bond. So but 2 in, but 2 in, as well as aldehyde functional group is there. So aldehyde functional group present means while naming time we need to use Al. So the product name is but 2 in Al. Or this common name for this compound aldehyde is there. So we can call this compound as crotonaldehyde. Crotonaldehyde. So these are the steps involved in Aldol condensation reaction. So once again I will repeat, the mechanism will be occurs by 4 steps. First step, removal of alpha hydrogen atom from one aldehyde by using one base. We will get the product as carbanion. Then second step, this carbanion attack, this carbanion is also called as an nucleophile. So this nucleophile attacks another aldehyde, and we will get the product as what? Alkoxide ion. In the second step, in this alkoxide ion, we are adding one proton. That step is called as an protonation of alkoxide ion, right? Then fourth step, we are getting this product, 3-hydroxybutanol. Just we are eliminating water molecule by heating. Just we are eliminating our water molecule. This structure we can write like this for our convenient purpose. Just for eliminating the water molecule, we are writing like this. So we are getting the product as but 2 in Al. So that's all mechanism. Now from the mechanism, we need to write the overall reaction for this reaction. So mechanism over. So while writing the reaction, just you write it in one step. So our rule is we need to use 2 aldehyde. I told you, as well as we need to use one bases also. In this aldol condensation, we are using sodium hydroxide. So our reaction of aldol condensation mechanism over. So mechanism occurs by 4 steps. Now we are going to write final reaction for aldol condensation. So we are using 2 moles of aldehyde. So which aldehyde we are using? Acetaldehyde, right? Now you write this acetaldehyde like this: CH3, C double bond O, single bond H plus CH2, single bond H, CHO. Both the both the compounds are aldehyde, acetaldehyde. Both the compounds are aldehydes only, acetaldehyde. Just for our convenient purpose only, we have written like this. Both are aldehyde only. Check it. Acetaldehyde formula CH3CHO. CH3CHO. Here you see CH3CHO. So it undergoes reaction by using base. 3 bases we can use. Sodium hydroxide we can use, potassium hydroxide we can use, or barium hydroxide. In this reaction we are using dilute sodium hydroxide. So directly we can write the product. So our product is 3-hydroxybutanol. 3-hydroxybutanol. So our product is CH3, CHOH, CH2, CHO. So this hydrogen will comes here. This becomes O minus. This will comes here OH. So our product is CH3. This we can write together CH. This H will comes here OH. CH2 CHO. So this is an reaction involved in Aldol condensation reaction. So that's all. Just you learn this Aldol condensation mechanism. This mechanism is very important question. So the mechanism will be takes place by 4 steps. Reaction together we have written by using 1 step. Just this H plus proton will shift here. O minus, this H will add here OH. So we are getting the product as 3-hydroxybutanol. So this is a reaction of aldol condensation. This is a mechanism. So the mechanism will be occurs by 4 steps. So thank you students.